bet you didn't know that juggling balls and variables actually have a lot in common with each other. I certainly didn't when I first started coding. You see, each ball represents a different value, and just like variables in programming, you have to keep track of which is which. But before we can start off with the comparisons, let's start with the basics. Two common questions I get asked by students learning variables for the first time is what is a variable and why do we need them? So let's start with the first question. What is a variable? Simply put, a variable is a way to store data in your program. Most of programming is storing and manipulating data, so learning how to create variables is a fundamental skill. I like to think of variables like a box. I want you to imagine a box with a label on the front. That label is the variable's name, and the value inside the box is the data we're storing. Now, the second question is, why do we need them? Well, variables make our code easier to read, easier to update, and easier to debug. Imagine you're writing a program where you need to print your age in 5 different places. You could type the number each time, but what happens when your birthday comes around and you're a year older? You'd have to hunt down every place and update that number manually. But variables fix this. You could assign your age to a variable, and then you'd only have to update it in one place. Cleaner code, less chaos. So now that we've covered the what and the why, let's cover the how. How would I create a variable that stores the number 5? Well, I would write int a equals 5. Let's break this down. To create a variable that stores a value, there are 5 different parts to it. The data type, variable name, assignment operator, value, and semicolon. First up is data type. In this example, I have an integer, which is storing positive and negative whole numbers. So I'm telling the computer that the value I'm storing is a whole number, 5. Now, every variable needs a data type for 2 different reasons. The first one is to determine how much memory the computer needs to reserve to store the value. And the second one is how the value should behave. Now, what do I mean by behave? I mean, is the value an integer? Can it be used in operations like addition and subtraction? Or can it be concatenated like a string can? Things like that. Now, up next we have variables. Now, variables are the names that we as programmers will use to reference the value throughout our code. And these names are arbitrary. They can be named anything, but they should be descriptive and describe the value that you're storing. So for example, if I was storing the oven temperature into a variable, I might name my variable oven temp, with the value being 350 degrees. Now, following the variable, we have the assignment operator. Now, the assignment operator's job is to take the value on the right and assign it to the variable on the left. The assignment operator always works right to left. It will never assign a value on the left to a variable on the right because that's not how we write our variables. The variable always goes on the left and the value always goes on the right. And then on the other side of our assignment operator, we have our value. This is the actual piece of data that we're storing inside our variable. So this can be anything, really, a number, a character, a sentence. Any piece of data that you need to store in a variable would go here. And then lastly is just that semicolon, which always goes on the end of each line in C++. Now, the way that we just declared that variable is called initializing a variable. It is creating our box with a variable on the front and storing our value inside of the box. There's a second way of creating a variable. It's called declaring a variable. That's taking the data type, the variable name, but ending it with the semicolon. That's because we're creating the box with our label in the front, but we are not putting any value inside of the box yet. In fact, the computer just assigns it a random value. We call this a garbage value. So to create this in code, it would look like int b semicolon. Then later on, when you're ready to assign your variable a value, you would just do b equals value with a semicolon. With that being said, there's 2 things I want to talk about. The first one is talking about this garbage value a little bit more. When you declare a variable in your program, you yourself do not initially give it a value, but the computer is going to give it a value. We call this a garbage value. So here I've declared a variable int b, and I'm going to print it out so that you can see what I mean by this garbage value. So I'm going to run this with warnings. So as you can see here, it's telling me B is used uninitialized. I'm using B and I haven't initialized it yet. But it's okay, it's just a warning. I'm going to run it anyway. As we can see, it's saying B is currently holding 612. But watch what happens when I run it again. And again. And again. And again. Each time, it is saying that B is a different value. Well, why is the number different each time, you might ask? Well, every time the program runs, the computer picks a spot in memory to store the variable, and it's not guaranteed to be the same spot each time. Since we didn't give B an initial value, the computer just uses whatever leftover data is already sitting in that memory location. And that leftover data is what we call a garbage value. And because the memory location might change with every time you run the program, the leftover data is different too. So that's why B can look different each time you run it. Now, the second thing I want to talk about is why I don't put the data type in front of the variable when I'm doing B equals 10. And the reason is because the box for B has already been created. All we're doing is taking out the garbage value and putting our new value inside. If I were to put the data type again, I would get something called a redeclaration error. Now, what is a redeclaration error? Well, if you put that data type in front of B again, the computer thinks you're trying to create two different variables with the same name, which isn't allowed. Variable names must be unique to each other. If that doesn't make sense, let me tell it this way. Take these two juggling balls, for example. They are identical to each other. Now imagine they were both called black and gray balls, and you asked me to hand you the black and gray ball. I'm not going to know which one you're talking about because they're identical to each other and they're both called black and gray. But if I had a variable called green ball and a variable called blue ball, and you asked me to hand you the green ball, I'm going to know exactly which one you're talking about because these variable names are unique. These variable names are not. I would not know which one to hand you. So that is why variable names need to be unique from each other. And that is also why if you try to add that data type in front of B equals 10, it's going to think you're trying to create a second variable with the same name, and it's going to give you what's called a redeclaration error. Now, before we move on, I want you to take a second and write down your own definition of what is a variable, why do we need them, the difference between declaring and initializing a variable, and what is a redeclaration error. The reason I want you to do this is because I have found that the best way to learn is to teach somebody else. You figure out really fast what you know and what you don't actually know when you try and explain a concept to somebody. So by writing down your own definitions, you're helping yourself understand the concept on a deeper level. You can also help somebody else by putting your explanations in the comments for people who need 1, 2, 3, or more different ways of explaining the same concept in order to understand it fully. Now let's talk about changing an existing variable's value. My original variable is int c equals 10. If I wanted to change this, I would just do my variable name, the assignment operator, my new value, and the semicolon. So I could do c equals 20, c equals 30, c equals 40, etc., etc. Now the only thing is once you create a variable of a certain type, you're locked into that type. You can only reassign it with values that are compatible. So for example, all of the number data types are compatible with each other. You could put a float inside of an integer variable. It would just cut off the decimal at the end. Or you could put an integer inside of a float variable. It would just add a 0.0 at the end. But you couldn't put a string inside a variable meant for an integer because numbers and strings are not compatible with each other. Now you can try this for yourself, but if you try and put one data type into a variable meant for another data type, you're going to get an error that looks like this. It's called an invalid conversion, and it'll tell you right here what the two data types are that are incompatible with each other. The only other thing I'll say about this is you can do this as many times as you need to. There is no limit to how many times you can reassign a variable's value. Now another error that pops up frequently is variable was not declared in the scope. Now I want to use this example specifically. Now in this example, I have two variables created, blue and green, and I'm printing out both of these variables. However, the green variable is created below the C outline. Now we can already tell that this is going to give me an error because there's a red squiggly saying green is undefined. But let's try it anyway. I'm going to run this program, and there's my error. Error. Green was not declared in this scope. But why is this? I technically do have a green variable. It's just created below the reference. Now, computers will read programs top to bottom. Unless they are told to go somewhere else, they will read it top to bottom. So what's happening in this example is we're starting at the top and we're creating a variable called blue. So our memory says, great, I have a blue variable created in my memory. Then we get to the print line, print blue, and our computer goes, I have a blue variable in my memory. I know exactly what you're talking about. Here's the value. Then we go to the next line and it says print green, but my memory says I don't have a green variable. I have never seen a green variable before. I have only seen a blue variable since we started this program. That's why it throws the error, because we don't create the green variable until after that line. So it's after that line that our computer will go, great, here is my green variable. I have it in memory. But before that, we only have blue. So to fix this, all I have to do is move the creation of the variable above when I need to use it. The rule is all variables must be created before any instance of referencing them. That way they can go into memory so that by the time you need to use them, the computer can say, yes, I have it in memory, here's the value, you can use it. So if we save this and rerun it, we can see that it now works and it prints out 10 and 20 like it's supposed to. One more time for my visual learners. This works because when the computer reads a program top to bottom, I'm saying, yes, here's the creation of my blue variable, here's the creation of my green variable, and when it gets to those print statements, both of these variables are now in memory. So when it says print blue, the computer says, yes, here is blue in memory, here's the value so that you can use it, and here's my green variable in memory, here's the value so that you can use it. Both variables have already been stored in memory, so I can reference them later. Moving on, earlier we talked about why variable names need to be unique, but now I want to talk about how to name your variables. There are a couple rules when it comes to it. The first rule is variables must start with a letter or an underscore. Examples of invalid variable names would be the number 1 invalid or @ invalid because these do not start with a letter or an underscore. The second rule is variable names can only have letters, digits, and underscores. So you wouldn't be able to have a variable name that has a symbol or a dash inside of it. Now the third rule is your variable names cannot solely be the C++ keywords. C++ has some keywords like int, float, return, for, while, that all let the computer know you're doing a specific thing. So your variable names cannot solely be these words. They can, however, contain these words. You can have variable names like return here or while on, but you cannot have your variable names solely be these words because the computer will think that you're trying to use a keyword. Now, the fourth rule is all variables are case sensitive. That means if you have a word score that's all lowercase letters, and you have another variable score with a capital S, those are technically unique variable names. Even though they're the same word, you have one character that's different. You have a lowercase s and you have an uppercase S. Take these two juggling balls, for instance. They're both the same color green, but one is a solid green and one is green and black. So these would be unique variable names. The computer would see these as two different variables. Now, these are not rules, but these are popular naming conventions that programmers use to style their variable names. We have camelCase, snakecase, and pascalcase. So camelCase is where each word starts with a capital letter, except the first one. That one is lowercase. Then snakecase is where all letters are lowercase, but each word is separated by an underscore. And then pascalcase is where each word starts with a capital letter, including the first one. I personally use camelCase, but the most important thing is whichever case you decide to use, you stick with that. You shouldn't have a program that uses all of these cases to style your variable names. You want to keep it consistent. Now, these are not all of the naming conventions, but these are the most popular. So you can look up the naming conventions, figure out which one you like the best, and then use that one and stay consistent. Now, let's talk about why descriptive variable names are a must. Right now, you can clearly tell that I'm juggling a green ball, a blue ball, and a red ball. But what happens when the color goes out? You don't know where that blue ball is, do you? And the more time that passes, the more you really don't know which one that blue ball is. You were wondering, was it this one? What about this one? Or this one? Or this one? And when the color switches back on, you're going to realize blue wasn't even in the mix anymore. The same thing happens with variables. If you name your variables something non-descriptive, like A, B, C, D, E, F, G, you're going to run into some major issues. The first being, I guarantee you are going to forget what your variables are for. It is good practice to name your variables something descriptive. Oven temperature, cook time, number of servings, ingredient 1, ingredient 2, anything that describes the value that you are storing. The second issue you might run into is if this is a group project. Your classmates or coworkers are not going to know what your project is about if you give your variables names like A, B, thing 1, thing 2, anything that is non-descriptive. Now, we've touched briefly on memory throughout this video, so as one last thing, I want to take a second and briefly go through how variables are actually stored in memory for those wondering. Local variables are stored in RAM, random access memory, specifically in a region called the stack, and the stack is like a vertical storage space that grows downward in memory. Think of it like this. Imagine a hook on the ceiling. This is the base pointer. It marks the start of the stack and helps the program find the first variable created. Every time you create a variable, you're creating the quote-unquote box that gets hung on the hook or on the bottom of the previous box. A stack pointer keeps track of the next available space for a box. It moves down with each variable. When your program finishes or a function ends, the boxes are then removed in reverse order, one by one from the bottom up, leaving just the hook, the base pointer, and the stack pointer. Now, we went over so many things today. I hope you learned something. If you want a PDF of all of these points summarized into a PDF note sheet, I already did it. It's linked down in the description and it's free to download. My email is also down there if you have any questions or want to reach out. Alright, that's it for today, but thank you for watching. And I'll see you in the next one.